Very good evening, student. Now we are going to start the important topic today. I would like to discuss the gravitational field and what is the gravitational field and what is the basic conceptual relation with the mathematics of gravitational field intensity. Okay, so gravitational field gravitational field is simply the word is field. Do you know the field? Cricket field, football field, different kinds of field means if you change the field, then the application of Newtonian mechanics and force applied will be different kinds of force will be changed. So gravitational field is simply talk about the laws of gravitational force of attraction. So we can define it in a simple word, the space statement, the space around which any object or body experienced gravitational force of attraction, experienced gravitational force of attraction. Such a phenomenon is called gravitational field. Gravitational force of attraction in the field, in the gravitational field. Dear student, the electric field, the space around charge in which any other charge experience electrostatic field. So the field will be changed. So you cannot any charge elementary particle attract or repel for any vacuum place. So we have to, and magnet also attract and repel in a specific place and a specific distance of gravitational force. Like two magnet are magnetic force, electrostatic force, and gravitational force. These all kinds of force are conservative force. So it will be applied in any field. So where the gravitational field, we feel or experience a gravitational force of attraction means this field is a gravitational field. So in the gravitational field, there is some path where we can assume the intensity of gravitation. So simply the next means we are going to start the gravitational field intensity. Gravitational field intensity. Intensity means, do you know? Intensity means ability to direction and take off any path. Intensity means, just example, the light are glowing in the earlier age. We are starting, the light is growing, heating, in the time taken. So intensity of the light, intensity of the sage, electromagnetic waves, radiation will be increased. There's such kind of gravitational field. Intensity of the gravitational field means the ability to attract any object or body, and their capacity is light for any specific ability is consumed. Let's see. Means if you beyond this any pen is out of the earth, so their gravitational force of attraction will be changed. If this pen is going to be center of the core of the earth, the gravitational fields of attraction intensity is 0. So simply in the beginning stage, we know that we derive the formula of force of gravitational force of attraction of mechanism. F is equal to gm square upon r square. This is the basic definition of the gravitational force. So second equation, when F is equal to mg, mass due to gravity, where we apply both the force, then we derive mg is equal to g m square upon r square. So square the mass is cancelled out. So g is equal to g m upon r square. You have already discussed the assertion due to gravity is the equation of mathematical g m upon r square, where g is the assertion due to gravity and capital G is a universal gravitational constant, and its value is 6.67 into 10 to the power minus 11 Newton meter per kg square. So this is g and the relation of the small g and capital G. Here we derive the intensity of, so intensity is represented, E is F, and force per unit mass of test mass. So this is a vector quantity. Intensity of gravitational field intensity, it is a vector quantity. So you can say E is equal to, the force, the simple formula is put in here. So G is equal to m square upon r square and m. Simply we solve it, square root this is cancelled out. So E is the intensity will be find out G m upon r square. What you observe? This G, assertion due to gravity, is gm upon r square. Intensity of the gravitational field is same, gm upon r square. Both are the same formula. So what is the difference between them? This is applied for any field assertion due to gravity to object attracts any other object, and this intensity is decided by how much ability to of any and intense ability of any gravitational field to attract any object or body. So both the formulas. So you can say G is equal to assertion due to gravity is equal to E intensity of the electron. Intensity, gravitational field intensity. You can ask an examination for it as a 1 marks. Second concept. You can gravitational field intensity. You can say the force per unit test mass is called gravitational field intensity. Gravitational field intensity. Intensity means path, right? Means, just an example, we can say this is a south pole magnet, this is a north pole magnet. So there is some field where they can attract or repel. Otherwise, if you are north pole magnet here and south pole, the magnetic force is not applied. If you are trying to be there infinite charge in the earth, so they are not attract and repel. So they have to be create any intensity line. So all the conservative force are dependent on their specific field. So gravitational field is also occurs in any field, and their intensity means distance or is also dependent. So you can say intensity. Gravitational field intensity basic concept, it is a vector quantity. What is vector quantity? Any physical quantity which have magnitude as well as direction. So gravitational field intensity have magnitude as well as direction. Second concept, what is the dimension formula and units and dimension of gravitational field intensity. Unit is force per unit test mass, that is Newton per kg. Newton per kg is the unit. So you can say Newton per kg. And secondly, you can say if you derive it from the dimension, so force is equal to mass into acceleration. So m into t per minus 2 upon m, this is m. So m cancel out. So this is dimension of m dot L t per minus 2. This is the dimension formula. Don't be confused. You derive the gravitational field intensity gm by r square. So you don't need to be try to be solved from the dimension formula. You can simply derive the units and dimension from here. The force is equal to SI unit Newton and mass is the kg. So simply the gravitational field intensity units is Newton per kg, and if you want to solve with the dimension, so easily force is equal to mass into acceleration, and mass is cancelled out, so acceleration is equal to LT per minus 2. Simply you can solve the units and dimension, right? So the basic concept is how you can memorize it. So just keep in from the starting point, the gravitational force of attraction, where we discuss about the force of attraction between the two masses is directly proportional to each other and inversely proportional to the square of the distance between them. Where we develop the force relation G(mm) upon r square in the first day. Second day, force is equal to gravity, mass into gravity, any object which is pull towards the center of the earth with the mg value. Third one is both the relation acceleration due to gravity and gravitational field intensity are both are equal or equivalent, both are vector quantity. Simply the force per unit mass. Force per unit mass, test mass is called gravitational field intensity. So means keep in mind with the series, the first concept is, first one is what is gravitational field and what is gravitational field intensity. Gravitational field is nothing, it is a field where the gravitational force of attraction can be experienced. And gravitational field intensity, the force per unit mass. In a simply you can keep in mind for memorization. Third one is force is equal for the one concept in the many competition examination for foundation also, and NEET and IITs many times they ask the question, the relation, what is the relation between the acceleration due to gravity and the gravitational field intensity. So where acceleration due to gravity G is equal to gravitational field intensity, both are equivalent. Okay, thank you so much.